Welcome to my major PT for this year's midterm. Actually, this has been a long-standing tradition of this channel, to which I've been creating multiple videos to pass to our math teachers who do not fail math and to proceed to the next quarter. So anyways, let's start by addressing a couple of problems which I particularly picked to discuss in this video. So that's gonna be an ellipse problem and a general to standard problem. So without any further ado, let's start with the ellipse part of the video first. So that's going to be our given problem for the ellipse concept is x minus 6 squared. Let me just finish this in a couple of minutes because I'm holding in the urge to take a number 2 plus 2 squared 16 minus 1. So ellipse, what do we know about ellipse and how to solve it? So basically ellipse, how to solve it is you just look which value has the greater value between each of them, and then once you get the greater value, you have that as your major axis, and you have that particular axis to be defined as your major axis. So first of all, in order to completely graph this particular set of problems, we'll have to address the couple factors that we'll have to fill in. Center, a squared, b squared, c, major axis, and then the foci. Now, how do we get the center? So you look at the two values up top of the equation. So that's going to be x minus 6 squared plus y plus 2 squared. So you simply convert the operations between each of them. So it's negative 6, positive 6, positive 2, negative 2. Now once we have the center sorted out, let's deal the a squared, b squared, c squared letter thing. So the way we define a squared and b squared is a is major axis, b is minor axis, and then c is the answer when you subtract the a squared and the b squared to get your square and then use it in your foci. Now, a square, our major axis, is 36, so we already have an answer to the major axis over here. So 36 belongs in the x-axis, so let's put x-axis as our major axis. Now once we have that, we'll fill in our minor axis, which is 16. What we're gonna do is to get the square of both numbers. So let's get 36 square root of 36, sorry, is 6. Square root of 16 is 4. Now once we have these particular answers, let's then tackle C. Now C is basically you subtract 36 minus 16, and then once you get that answer, it's going to be 20. And to my knowledge, the way you deal with this particular not a perfect square situation, you simply 5 times 4 is 20. You divide 4 by 2, so that's going to be 2. So you're gonna get 2 square root of 5. You can just imagine the process, but yeah, that's how you get it over there. So anyways, once we have our foci, that's going to be 6 plus minus 2 square root of 5, and then comma negative 2. Now we have the particular set of factors that we need to start graphing. So let's start graphing. Alright, so apologies, I don't have a ruler with me as of this moment, so we'll just have to use my drill kit. And yeah, hold on just a second, let's draw this line. I don't have graphing paper with me here in my hometown, by the way, so we'll have to settle with not really an incorrect, but more of an inaccurate way of graphing. But here we are. We have drawn our graphing, not really paper, but yeah, let's just go ahead and find our center. So that's going to be in, I believe, the fourth quadrant. So 0, 1, 2, 3, 4, 5, and 6. And once we have that filled up, we're just going to put 1, 2, it's going to be negative 2. So our center is right over here. And what we're going to do is, since 6 is the major axis, we just count 6 up, 6 left, 6 right, and then 6 down. Now, 6, right? So 1, 2, 3, 4, 5, and then 6. 6 up. 1, 2, 3, 4, 5, and then 6. Apologies for my inaccurate drawing. 1, 2, 3, 4, 5, and then 6. And then 1, 2, 3, 4, 5, and then 6. And once we have that filled up, let's draw our what seems to be an ellipse but is truly just an oblate spheroid. Oh my god. Alright, so anyways, what we're gonna do is to just analyze where the foci is going to be. So I believe that's going to be around 1, 2, 3, 4, 5. Now that's gonna be between 4 and 5. So I believe here is our first foci. So F1, and that's going to be 6 plus 2, sort of 5, and then comma negative 2, while our other one is in 1, 2, 3, 4, and 5. Okay, so it's right over here, and that's going to be our second foci. So that's going to be 6 minus 2 square root of 5, and then negative 2. So that's how you graph an ellipse. And yeah, once we have this done, let's move on to the other part of the video, which is okay, oh god. So this one is going to be a little bit interesting, since I promised, no, I told myself that I would know this part of the circle, but actually it's, hold on. So what we're gonna do is to find the general equation of a circle whose endpoints of the diameter are negative 1 and 6 and 7 and 4. So I thought that this part of the test was going to be easy for me in the quarter test, but somehow I forgot the midpoint formula and I got my brain scrambled over. But anyways, let's solve this particular problem. So what do? Yeah, we just do midpoint formula to get center. We use the center from the midpoint so we use the center from the midpoint formula to the distance formula to get our radius. And once we got our radius, we basically have a complete standard form that we can put in here. So anyways, let's go. So x midpoint is equals to x sub 1 plus x sub 2 over 2, and then equals y midpoint is equals to y sub 1 plus y sub 2 over 2 equals. Okay, so what we're gonna do is just look over here. Alright, so both of our x's are over here, so that's going to be when you minus, no, you don't minus, you just plus. So you got negative 1, 7. So that's going to be 6. 6 divided by 2 is 3. Nice. And then 6 plus 4 is 10. Divided by 2 is 5. Alright. Yes. Alright. Don't mind me. Alright, so center. We got our center already. Feels great. So center is 3 and 5. Ain't that fabulous? And then we'll use 7 and 4 for our what was that thing? Our distance formula. We'll use 7 and 4 for distance formula. So anyways, let's go ahead and start. So yeah. R is equals to x minus h plus y minus k, and then 2. So what we're going to do is to fill in the blanks. So our x, 7, our h is 3, so squared, plus our y is 4, and our k is 5, and that's going to be raised to 2. So what we have here is 4 squared plus negative 1 squared, and then that is not as, alright, there we go, Then what we have is 16 plus 1, and we get 17. So our r squared is going to be 17. So once we have that, we essentially have, well, what we need. Yeah, so we just look here, we convert x minus 3, since they're both positive, x minus 3 squared, and then plus y minus 5 squared equals r squared is going to be 17, and we have our standard equation. It's right over here. I can't believe this was actually this easy. I completely forgot about the plus sign in the midpoint formula, so I put minus there in my test. So anyways, that's an error on my part. So finally, we'll graph. Thank God. Let's get this over with. Right. So I think the closest. All right, we actually gotta find the closest. The closest, what do you call this, radius to 17, the closest square to 17. So that's going to be 4, or somewhere around the line. So let's just put in 4. So center is 3 and 5. So let's put our x is 3. So let's put 1, 2, and 3. So 3 is over here, while our 5 is going up. So that's going to be 1, 2, 3, 4, and 5. It's going to be right here. So since the closest square root we have to 17 is 16, so it's going to be 4. So we just count. So it's going to be 1, 2, 3, and a little bit of 4, so it's like 3.5. So let's just put it right here, and then 1, 2, 3, and then 3.5. Then 1, 2, 3, and then this is gonna be right here, and then 1, 2, 3, and then it's just gonna be right here. Now since we have, okay, that don't exactly look like a perfect circle, but yeah, so anyways, just remember, when you have a not perfect square, so when you get the nearest square to it, 16 for example, right, you just basically count like at least half and not exactly 4, so you can show that it's not 4, but it's somewhere along the lines of 4.1, 4 point, it's like 4.123 or something. So yeah, our math teacher is generous enough to not require us to solve the exact thing to graph. So anyways, yeah, that's how you deal with turning general equation into standard equation. So midpoint, get the center, combine with the you choose which to use to get the radius, and once you get the radius, you have your standard equation to use, and then you can just graph away all you want. So anyways, that was just that's it for my math PT, and I sure do hope that this will allow me to get back on my feet regarding my pre-calculus grade. So yeah, anyways, thanks for watching, and I'll see you on the next PT, which is probably gonna be in next month.